Hey everybody, welcome to InterviewBlog. In this video, we'll be covering a question, search in sorted matrix. So the question gives us a two-dimensional matrix and also a target value, and the question wants us to determine whether the target value is present in the matrix or not. If the target value is present in the matrix, then we are supposed to return the position of the target in the matrix. And if the target value is not present in the matrix, then we have to return -1, -1. Once I hear this problem, my straightforward solution or naive solution would be traversing each and every column of the given matrix and checking each and every element if it is equal to my target value. So this solution has a time complexity of big O of n cross m. Why is it n cross m? Because there are a total of n rows and m columns, which means that we are traversing m number of elements n number of times. Therefore, our time complexity tends to be big O of n cross m. So can we do better? Please note that this solution works fine when the matrix elements are in unsorted fashion. But in this case, we have to use the fact that the matrix is in sorted fashion. The tricky part here is to think about a solution which uses the fact that the given input matrix is sorted and thereby reducing the time complexity. So let us now pick a random value from our input matrix and compare that value with our target value. Let's say I pick this 14. So what I will do is I will compare this 14 with the target value. By comparing this, we can find that our 10, that is our target value, is less than 14. So what does it mean? From this situation, we can find that the numbers that are after 14 will never have our target value. We can also find that the numbers below this 14 would never have our target value 10. So therefore, we can eliminate this part of our matrix. That is, we never have to search this part of our matrix to find our target. So let us now start from the upper right corner element, that is 19. So when we compare this 19 with the target value, we see that 10 is less than 19, which means we can eliminate this part of our matrix. That is, the elements below 19 will never contain our target value, which is 10. Now have to decrement the column index, which means now we'll go to this 11. While comparing this 11 with our target value, we find that 11 is greater than 10, which again means that our target value 10 will never be in this part of our input matrix. So we will again be decrementing the column index, and we will now compare this 9 to our target value. Now, while comparing 9 to our target value, we can find that 9 is smaller than 10. So this means the elements before 9 will always be smaller than our target value, which is 10, and hence we never need to search for our target value in this part of the input matrix. So now I'll be incrementing my row index. I will reach this 14. So now I'll be comparing this 14 to my target value, and we can find that 14 is greater than 10. Now, since 14 is greater than 10, we never want to search for our target value in the elements which are right below 14. So what will we do now is we will be decrementing our column index. So now we'll be comparing this 10 to our target value, and since 10 is equal to our target value, we will now be returning the row and column index, which in this case is 2 and 1. Actually, this is the route that we took to find our target value. So let us now discuss the complexity of this solution. Now, the space complexity of our solution tends to be big O of 1, that is constant space, because we did not use any extra space or any extra auxiliary data structure to solve this problem. So our space complexity tends to be big O of 1, whereas our time complexity tends to be n plus m, where n is the number of rows and m is the number of columns in the input matrix. Why it is n plus m? Let's say our target value is now 5. So what will we do? In this case, I will again be starting from this 19. Now what I will do is I'll compare this 19 to my target value, which is 5. we can see that this 19 is greater than 5, and hence my target value will never be below this 19, and so I will be decrementing my column index, and now I'll be reaching this 11. Now I will check this 11 to the target value, which is 5. Now since 11 is greater than 5, I will again eliminate the elements below this 11, and I'll be decrementing my column index, and now I'll be reaching this 9. And since 9 is also greater than 5, I will again eliminate the elements below this 9 and decrement my column index, and now I'll be reaching 8. And while comparing 8 with 5, we can see that 8 is greater than 5. So again, I will eliminate the elements which are below 8, and I'll be decrementing my column index, and hence now I'll reach 1. And since 1 is now less than 5, so this means I'll be incrementing my row index. So now I'll reach 2. Now while comparing 2 with 5, we can see that 2 is less than 5, and hence I will again be incrementing my row index. Now I'll check for 3 and 5, and we can see that 3 is less than 5. Hence I will again be incrementing my row index. Now I will reach 5, and since 5 is equal to my target value, I will be returning the row and column index, which in this case is 3, 0. So as you can see, in this case where our target tends to be 5, we have traversed one entire column and one entire row. So this gives us a time complexity of n plus m, where n is the number of rows and m is the number of columns. Therefore, our time complexity tends to be big O of n plus m. So now, what if the target value is not present in the matrix? Let's say our target value is now 6. In this case, we'll start from this 19. We'll be traversing the matrix this way. We'll finally reach this 5. And after reaching this 5, we can see that 5 is less than our target value, which is 6. And hence our row index will be incremented. But as you can see that there is no row available after incrementing this index. This is the end, and 6 is not present in our input matrix. Hence our function would return -1, -1. So hope you understood the explanation part of our solution. Let us now implement it in code. So we got our search in sorted matrix function defined, which takes in a 2D matrix and a target value, which is an integer. So now, as discussed earlier in the explanation part, we will be starting from the top right element in the 2D matrix. So this top right element has a row index of 0, and the column index of this top right element would be length of the first row -1. So these two indices refers to the element at the top right corner of the 2D array matrix. So I'll be iterating the array until the row and column indexes are valid. That is, my row index should not exceed the length of matrix, which is the maximum number of rows that are available in the given input matrix. And my column index should always be greater than, or it should be 0. So in this case, my current value is the element which is currently present in the given row and column indices. What will I do now? Now I will compare my target with the current value. That is, if the target element is less than current value, in this case, what I will do is I will just decrement my column index. Or if my target value is greater than my current value, in this case, I will increment my row index. Or if my target is equal to my current value, then I will be returning the index. Once I finish traversing the entire matrix, if I still didn't find the element, I should be returning -1, -1. So this is our solution. Our solution has a time complexity of big O of n plus m and a space complexity of big O of 1, where n is the number of rows in the given matrix and m is the number of columns in the given matrix. Now we'll copy and test this solution. So this is Leetcode problem number 240, which is search a 2D matrix 2. This is the same problem that we discussed now. So I'm just going to paste my solution and make sure that it runs properly. So I'll be saying return search in sorted matrix of matrix comma target. The only difference between our solution and this solution is that the output here is a Boolean value, whereas in our case we will be returning the indexes. So I'll be altering this to true, and if we couldn't find the given target value, we will be returning false. So our solution got accepted. Now we will check whether our solution passes all the test cases. So yeah, our solution got accepted. Hope you understood the problem. Do subscribe and check out our channel for more videos. Thank you so much.